So again, just a quick recap of what we did so far. Coefficient of our x squared times the number in the back, our constant, that's our m. Number in the middle is our a. You need to find two numbers that multiply to this, add to this. We came up with 14 and 2. They both have to be positive because they multiply to a positive and they add to a positive. You take these two numbers and you write them in parentheses with an x. You use those numbers to form two binomials, okay? So if you have 14 and 2, you need to write it as x plus 14, x plus 2, both positive. Remember, to factor means to rewrite as a multiplication problem. So here is our multiplication problem, okay? Now, the final step is to divide by your lead coefficient. The lead coefficient is the number in the front. The number in the front here is what? 1. Can you divide either of those numbers by 1? What's 14 divided by 1? What's 2 divided by 1? 2. So that step, you always need to stop and say, can I do that step? In this case, you can't, and that's our answer. If you want to box it in, go for it. If you want to check your work, you would just double distribute. You'd end up with x squared plus 2x plus 14x. That's how you get the plus 16x. And then in the back, you get plus 28. Sound good? That is factoring with a trinomial. Or factoring a trinomial. Questions? Yes, ma'am.
What happens to the 2? Should just go away the exponent.
Oh, so when you double distribute, x times x is how you get the x squared.
Okay.
So yeah, if this is an x squared, then we have x and x. If this would be like x to the 4th, you'd have x squared and x squared.
You wouldn't have to worry about the x2 when you multiply it by 28.
Right. That first step, you just do the 1, the coefficient of the x squared. Yep. All right, let's look at another one. All right, it's a trinomial. I have 3 terms with an x squared term, an x, and a constant. Do the coefficient times the constant to find my m. What's 1 times negative 21? Negative 21. And then the a is just your middle term. Now, the ways to multiply and make a negative always involves 1 positive and 1 negative. When you have 1 positive and 1 negative, the larger number has to have this sign so that when you add them, you keep that sign. Okay? So what are, just in general, ways to make a 21 through multiplication? You could do 1 and 21. You could do 7 and 3. 1 and 21 doesn't, like when you add those, you get 22. If you make one of them negative, you would get 20. That's not even close, right? What about the 7 and the 3? Do you think?
Negative 7 plus 3.
Yeah, if you do negative 7 and positive 3, those would multiply to give you the negative you want and add to give you the negative 4 that you want. So I think that's going to work out. That's not my actual answer, though. How would I write my answer? X minus 7, x plus 3. Before you box it in, divide both numbers by your lead coefficient of 1. Does that change anything? No. So we're good. If you want to check, you can double distribute. What are your questions? All right, here's your next one. All right, what's my M?
8.
What's my A?
-9.
Okay. If you want to multiply and get a positive,
-1 or -18.
what? You need to multiply to make a positive. So they either need to both be positive or both be negative. What do you think they both need to be if we're adding to a negative? 2 negatives, right. Does anyone know the 2 negatives that would multiply to +8 and add to -9? Yes.
-1,
-1 and -8. Good.
Does it matter which order you put them in?
Nope. All right, so since it's Y's, use Y's. Honestly, if you used X's, I probably wouldn't even notice. All right, and then divide by your lead coefficient. What's the lead coefficient here? 1. So do I really need to do it? Not really. Questions? Whoa. All right, let's just focus on the numbers for a second. So forget about those variables until we get to writing it in the binomials. So my M is still just 1 times -18, which is -18. My A is that middle term, 3. So I heard 3 and -6. I heard 6 and -3. Does anyone feel like they have an opinion one way or the other? There's a few people like whispering. Josh, what do you think?
6 and -3.
Why not 3 and -6?
Because 3 and -6 would make -3.
Right. We want the bigger one to be positive so that when we add them together, we get a positive. Good. So I'm going to do 6 and -3. Now, normally when I write them in binomials, I just put the first variable that was squared in the front, and that takes care of it. What do you think I also need?
You have to put the second variable behind.
Yeah, now I need to make sure that when I multiply my last 2 terms, I have a b times a b to get b squared. So it's the same idea. The a times the a will give us the a squared. In the back, if we want the -18 to have a b squared with it, we need to put a b with each of them, because b times b is how we're going to get b squared. If you're not feeling super sure, go ahead and go through the whole process. A times a is a squared. In the middle, we'd end up with -3ab plus 6ab, which gives us the positive 3ab. And then in the back, -18b squared. What are your questions? All right, now we're going to look at one that does not have a lead coefficient of 1, so it gets a little trickier. It's the same process, though. We're going to multiply the coefficient, the lead coefficient, times the constant. So the 2 times -24,
-48.
which is -48, and then our middle term
13.
gives us our A. I did 2 times -24. You got to multiply the first times the last, basically.
So 2 times -24, isn't it +48?
2 times -24. A positive times a negative is a negative. All right, can anyone think of two numbers that multiply to negative 48 and add to positive 13?
12 and negative 4.
12 and negative 4 would give us 8.
Is the,
But I saw another hand. Did you have it?
No,
uh,
what are we?
We're trying to find two numbers that multiply to this and add to this. You got it now?
316, the negative will be the 3.
The negative would be, so 3 and 16, good. We need to make one of them negative.
Which will be the 3.
We want it to be the smaller one so that when we add them, we get a positive. So these are the two winning numbers. Now we're going to write those in binomials. Here's where it gets a little different. Previously, we just thought like, oh, we'll divide by 1. Nothing changes. We're done. That's not what happens here. Because we don't have a lead coefficient of 1. We have a lead coefficient of 2. So we divide both of these numbers by 2. Okay? Now, 16 does divide by 2, right? You get 8. Can you divide 3 by 2 and get a whole number? No. Do you remember what I called this method? I called it the bottoms up method because when you end up with a bottom, you move it up. We take the 2 from the bottom and we move it up in front of the B. So it's 2b minus 3. That's why it's called bottoms up, because anytime we end up with a denominator, we move it up. You can even sing the song if you want. That was way popular, like, during my college years where I was just constantly studying in the library. I heard other kids listen to it, not me.
Was it like a Schoolhouse Rock, though?
No.
nothing like that.
No. All right, any questions? This is a tricky one. So we do it the same way we did the ones with the leader of 1. The only difference is to get my m, I multiply these two. And then once I have my binomials, I divide and kick all the bottoms back up. Questions? All right, I want you guys to try this one on your own. So see if you can come up with the M, see if you can come up with the A, find the combination that works, see if you can go through the whole process. I will give you 2 minutes. Starting now. That's not good. Oh, I'm still recording. That's great. What's your M?
Negative 36.
Negative 36. What's your B? Your B. Your A.
5.
Very good. Winning combination?
Positive 9, negative 4.
+9, -4. Great. So I'm going to write those numbers in binomials. So x plus 9, x minus 4. Am I done?
No.
What do I have to do?
Divide by 3.
Divide both of those numbers by 3. What is 9 divided by 3? 3. You cannot evenly divide 4 and 3. So what do I do now?
3x minus 4.
You move the bottom up. And that is our answer. And as always, if you're not sure if that's right, double distribute and see if you end up where you started. And in this case, we would. What are your questions? Yes.
You always put the bottom number in the second set.
Nope. You could write 3x minus 4 times x plus 3. That would be fine. It just happened to work out that it was in the back both times. All right, here's the next one. We can go ahead and do this one together. Yes, so my m's going to be positive 36. My a is going to be negative 13.
Negative 2 and 13.
They're going to need to both be negative, right? To multiply to a positive but add to a negative. So the ways to multiply to get a 36, like 1 and 36 doesn't work. 2 and 18 doesn't work. 3 and 12 doesn't work. 4 and 3?
Negative 4, negative 9.
4 and 9? Sorry, I couldn't hear what you said. 4 and 9 both negative? I think you got it. All right, so write it in binomials. So we have x minus 9. We have x minus 4. Box it in? No. What do I do? Divide by 6. Can either of those divide by 6? No. However, both of these fractions reduce. So reduce the fraction before you kick the bottom up. So 9 over 6 will reduce to what? 3 over 2, good. And 4 over 6 reduces to 2 over 3. All right, now we move the bottoms up. So what's my final answer? Yes, ma'am.
3x minus 2 and then 2x minus 2.
Very good. She said it in reverse order of what I have on the board. It's the same thing. So 2x minus 3 times 3x minus 2, or 3x minus 2 times 2x minus 3, as long as what's in parentheses is together, like you can't have 2x minus 2. That wouldn't work, okay? These guys go together, these guys go together, but you could write one in front of the other. It doesn't matter. Does that make sense? Am I saying it clearly? Okay. Questions? More practice.
Is this it?
I am sick.
Children?
Thank you for noticing.
Was it for your children?
My 2-year-old had croup.
What is that?
It's like a really bad cold where they cough and it sounds like a seal. And they like can't catch their breath, and but in adults it's just a cold. It's weird.
So adults can't get it?
Adults get it, but it's just a cold. But like if a baby gets it, they get real sick. It's yeah.
What's through talking?
It's been a miserable week, I'll tell you that. All right, let's do this. Multiply. Oh,
Wait, what?
hold on.
Huh? You can divide it all by 3.
Yeah, so here's the kicker. Bottoms up actually doesn't work if there's a common factor in your terms.
We were not taught that in non-algebra.
I believe you were. So, do you see how these each are divisible by 3? We cannot try bottoms up until we divide everything by 3. And I'm sorry, I didn't even catch that. I wasn't looking too closely. So good thing it popped up, or we would have done it incorrectly. We need to go through and divide each term by 3 first and write the GCF in the front. So now I have 3, and then in parentheses, x squared minus 3x minus 18. Now, when you do bottoms up, ignore the 3. You have to keep writing it. It's going to be in your answer. But when you do like the lead coefficient times the constant, don't use the 3. The 3 is no longer part of the trinomial. It's done. Okay, leave it out front. Done. So my m is just negative 18. My a is just negative 3. Other way around. Yeah, negative 6, positive 3. If you flip-flop them, you'd end up with positive 3 for your add number. All right, so I got to keep that 3 in the front, and then I have x minus 6, and I have x plus 3. Okay, this is the correct answer. Real quick, though, I want to show you what happens if you don't see the GCF. We already did. Oh, the lead coefficient now is 1. So, yeah, you divide both terms by 1, but nothing happens. All right. Can someone with a calculator do 3 times 54?
Negative 162.
Negative 162. So let's say we didn't do the GCF. This is the wrong way to do it. So don't write it down because it's wrong, but I want to show you what would happen. So, A is negative 9. What is 162 divided by 9? 18. Okay, so that'd be the winning combination, right? Negative 18 and 9. So if I did x minus 18 and I did x plus 9, then I divide by 3, right? Do you see how I end up right here? I end up with the same answer, but without the 3 part. And the way you'd catch this mistake is kind of just logically, right? Because if you do x times x, are you going to get 3x squared as your leading term? You are not, okay? So if you do bottoms up and they both reduce and you don't kick anything up to the front, you probably missed a GCF. Because you shouldn't just have x times x to get something other than 1x squared, okay? So again, if you do the bottoms up step and you're not moving anything in front of an x, you probably missed a GCF in the beginning and you're going to get it wrong, okay? Does that make sense? Because we almost did it, and I would have eventually caught it, but luckily it caught it for me. Questions? All right, what did we learn today?
Bottoms up.
Bottoms up, good. You could also call it factoring trinomials. Now, we are going to practice factoring trinomials for one more day of notes. Thursday's a review, Friday is a quiz, which means no homework over your 3-day weekend, so that's good.